What happens to entropy in an isolated system over time? Have you ever wondered what really happens to disorder in a closed system? Let's break it down in simple terms. In an isolated system, which does not exchange matter or energy with anything outside, entropy behaves in a specific way. Entropy is a measure of disorder, or how energy is spread out within that system. According to the second law of thermodynamics, the entropy in an isolated system can only increase or stay the same over time. This means that if the system starts off in a state that is not balanced, spontaneous changes will occur. These changes will lead to an increase in entropy, pushing the system toward a state of equilibrium. When the system reaches equilibrium, the entropy will stabilize at its highest possible value. At this point, no further changes will happen inside the system. It's like a room that starts messy and gradually becomes more organized until everything is in its place. Once it is organized, it stays that way unless something else disrupts it. Now, let's consider what happens when the system is not in equilibrium. Internal processes, such as energy moving around or chemical reactions, will occur naturally. These processes increase the system's entropy, reflecting a shift toward a more disordered state. For instance, if you have a container of hot coffee, the heat will spread out until the temperature is even throughout the coffee. This spreading out of energy is a perfect example of how entropy increases. It's also important to note that in an isolated system, entropy cannot decrease. There's no outside influence to help reduce disorder. Any local changes that might seem to lower entropy are always countered by larger increases elsewhere in the system. So, the overall trend is always toward more disorder, or, at the very least, no change. In practical terms, this principle helps explain why many natural processes lead to disorder. For example, if you mix different colors of paint, they will blend into a uniform color over time, increasing the system's entropy. So, to sum it up, in an isolated system, entropy will either increase or remain constant. It reflects the natural tendency for systems to become more disordered over time, especially when left alone. Understanding this concept can help us grasp why certain processes happen the way they do in our world.